Hello everyone, welcome you back to another video. So in the series of algorithms, so this is the fifth class. If you haven't seen all the classes, please go and watch. So in the previous classes, we did attend two kinds of questions. The two patterns we have discussed. One is when the operation part is incrementing with some constant value that is incrementing linearly. It may be decrementing linearly. And the second one is if it is getting multiplied by the constant term, right? So in that pattern, we are going to see one of the questions in which it is getting divided by some constant term. So let's see how to calculate if it is getting divided by some constant term. So here you can see that the operation part is different. So it is being operated, it is being divided by a constant term after each iteration, right? So what is the time complexity we are searching for? Time complexity is nothing but just the number of times the statements are getting executed, then we are adding those terms. Okay, so we have to find out how many number of times this loop will get executed and this statement will get executed, and then after that we can just add them and can find out how much is the time complexity. Okay, this process, let's see the question. Here the I value is being initialized with n. Okay, so n is initialized the I value, then it will get checked by this condition criteria. Okay, whether n is greater than equals to 1 or not. If it is greater than equals to 1, then we will be coming to loop statement, and then after the execution of this loop statement we are going to the operation part. Here the I value is first n now, then it will be getting updated as n by 3. Then the same checking condition, the checking procedure will be carried on. If it is true, then we are again coming to the loop statement. So this process will go on till what part? Till like this. Let's see, n by 9. Third time it is getting n by 9. Okay, greater than 1. So in this process, let's see after k time. Okay, after k time, the value of n by 3 power k is less than 1, or it is not greater than equals to 1. Okay, so the value of this is the 0th time. For example, this is the 1th, this is the 2nd time. So at kth time, I am taking like this. This will be on k time, this will be on k time. So my time complexity will be order of 2k. But here k is nothing there, so we need to find out the k value in terms of n. That is our main goal, right? So let's say at the kth time the value of n by 3 power k is not greater than equals to 1. So here the condition will get false and the statement, the iteration will stop. Okay, so that is we are searching the k value. Okay, so let's suppose n by 3 power k, okay, equals to 1, right? After, for example, we are taking n by 3 power k equals to 1. After that the iteration will get stopped. So n equals to 3 power k. Let's take the k log value because we want the k value. So we are taking the log value both sides. Log n equals to log 3 power k. So we know that if it is in exponent, it is in the exponent part, then it can come here. Here we want 1, so I am taking the base is 3. So here I will also take base 3. So k equals to log 3 base 3 is 1, and log 3 base n, this will be as it is. So k value we are getting log 3 log n base 3, right? So here this will be executed log n base 3 time. This will also get executed log n base 3 times. So at last we are getting 2 log n base 3. We can simply write it as order of log n base 3, right? So the pattern we have noticed, if the operation part is like, if it is incrementing by some constant value linearly or decrementing by some constant value, we are getting order of n. Operation part is like this. If it is getting multiplied and or it is getting divided by some constant part, then we are getting log n base k. We have noticed from previous class and today's class. So this is what we have read. Let's take some another cases and observe something more on this time complexity calculation. This is the third kind of question we are seeing here. Here you can observe that the updation part is quadratically incrementing or decrementing. Okay, so how to solve this kind of questions? Let's see. Let's solve this question first. Here the I value is 2 and it is operating till I value is less than n, and it is incrementing quadratically, right? After each iteration I square, the I value is getting updated by the value I square. So the same thing we just need to do for every question. Don't worried about by seeing the question. Just the fundamental thing you need to remember, how many number of times this loop getting executed, that thing we need to find out, right? So suppose the k number of time the loop will get executed, the condition will get satisfied. Okay, so this will also get executed k number of times. So at last we will be getting the time complexity is order of 2k. I value is getting initialized with 2. Now after each iteration this will be getting squared, right? So first it is like 2, then 4, then it will be 16, then 256. In this fashion this will go until the I value is less than equals to n. After when I value becomes n, after that the condition will get falsified and the iteration gets stopped. Okay, let's assume this is the 0th time, this is the 1 time, this is the second time, this is the third time. Let's suppose this is the kth time. Okay, so we need to find out what is the value of k. After the kth time the loop is getting stopped, so we need to find what is the value of k. Here you can notice some pattern, like this is, I can write it as 2 power 2 power 0. This can be write as 2 power 2 power 1, 2 power 2 power 2, 2 power 2 power 3. See here, 2 power 3 is 8 and 2 power 8 is 256. So in the same manner I can write it as 2 power 2 power k, 2 power 2 power k equals to n. So I need to find out what is the value of k, so I need to apply logarithm. 2 power k log 2 base 2 equals to log 2 log n base 2, right? This will be getting 1. So 2 power k equals to log 2 base n, and again k is at the exponent, I need to apply logarithm once again with base 2. So k log 2 base 2 equals to log 2 log 2 n. I am applying logarithm in both sides. So k value I am getting, this will be 1. So log of n. So what will be the answer? The answer will be order of log of n. It is getting quadratically incrementing. So you can notice that the logarithm value coming twice. So don't need to remember this. You can observe the pattern and actually you can solve the question directly. Come to this side. This is the question. Here the I is getting updated by its root value after each iteration. So let's suppose this will execute k time. This will also execute k time. We need to find out what is the value of k. The value of I is n initially, and after each time it is getting the root over value is getting updated. This is like n power 1 by 2, n power 1 by 4, then n power 1 by 8. So in this fashion this will come down to n power 1 by. So when this will when the loop will get terminated, when I value is becoming 2, in this manner when I value is becoming 2, then at this time I value is becoming 2. These are the I values, right? These are the I value I am writing. So let's suppose at this time I value is becoming 2 and the loop will get terminated. So I just want to find out is the term at which I value is becoming 2. Let's suppose this is the 0th term, this is the 1st term, this is the 2nd term, this is the 3rd term, this is the kth term. So here you can also find out some pattern. This is n power 1 by 2 power 0, right? This can be written as n power 1 by 2 power 1. This can be written as 1 by 2 power 2, n power 1 by 2 power 3. So this can be represented as n power 1 by 2 power k. N power 1 by 2 power k equals to 2. We just need to find out what is the value of k. So what is the value of k we need to find out. We are getting n power 1 by 2 power k equals to 2. Applying logarithm on both sides. So log base 2, I am taking the base is 2. Here I am getting 1 by 2 power k log n equals to 1. This will be log 2 base 2 is 1. So I can simply write it as 2 power k equals to log n. So the k is at the exponent place. So simply I can take logarithm both sides. K log 2 base 2 log n log n. Applying logarithm both sides, I am getting k equals to log n. So this is simply order of log n. Three things you must have observed. One thing, if the updation part is incrementing linearly or decrementing linearly, then it is order of n. If the updation part is incrementing by some multiplied by some constant term, or it is getting divided by some constant term, we are getting order of log n base k. When it is like squared or root over by something, the updation part, then we are getting order of log n. So these three things you can apply, and please look other things like what is the initialization part, what is the updation part. Don't use it blindly, right? Just the main thing you need to know, how many number of times the loops will get executed. That will be our time complexity. So I will bring some more questions to you so that you can get clarified over this time complexity calculation part. So thank you for today, and please like, share and subscribe, share with your friends. Thank you.